Hello everybody and welcome to lesson PA5-11 Variables. In this lesson, you will be able to substitute values for the variables in algebraic expressions and translate simple word problems into algebraic expressions. All this may sound really complicated, but trust me, it's not so bad if you come into it with an open mind. So let's start with the basics. Something like this, 2 times 3 plus 4, is what we call a numerical expression. Okay? This is an expression that we would try to solve. We would do first what's in brackets here. 3 plus 4 is 7. And then we would do the multiply that by 2. So the answer to this numerical expression is 14. Now if I replace some numbers with variables, then I have an algebraic expression. A variable is when I introduce a letter. Now for a lot of people these letters look scary, so let me just rewrite this algebraic expression like this. 2 times blank plus 4. That's all that n stands for. It's a placeholder for a number that we don't know. So an n or any other letter just represents a blank. Okay? When letters are used in an expression, the multiplication sign is often omitted to avoid confusion with the letter x and to make the notation shorter. So all that means is that 2 times n plus 4 is the same thing as 2n plus 4. This means that we do the n plus 4 first, and then we multiply that by 2. So we are going to rewrite the expression. So for example, 2 times n is the same thing as 2n. When you see a letter and a number next to each other, that means they are being multiplied. So if n was 3, for example, if n was 3, then 2n would mean 2 times 3, and so that expression would be worth 6. That would be the value of it. Okay? 2 times n plus 3, if we rewrite it, we can write it like this, 2n plus 3. Just means 2 is multiplied by n, and then we add 3. And then down here we would have 2n plus 3. Now whenever we're doing algebraic work or work with algebraic expressions, we have to follow what's called an order of operations. And some people like to call it bedmass because the letters here spell bedmass. Now I'm going to simplify this a bit. We don't need to worry about exponents. For our purposes here, we're going to cross out exponents, okay? All we have to worry about is if there are brackets, like we had brackets in a number of expressions up here, brackets, whatever's in brackets always has to happen first, okay? After that, division or multiplication take precedence next, and you do them from left to right. So that's the second thing. And finally, addition and subtraction from left to right happen last. So you're just remembering these 3 steps. First brackets, then division, multiplication, then addition or subtraction. So we have a table. We have 3 figures, and each one has a number of blocks. So here we could see that figure 1 has 1, 2, 3, 4, 5 blocks. If you were to count them, figure 2 has 6 blocks. Whoops. And figure 7 has 7 blocks. So each time we added 1 more block. Now we're concerned about how the figure number turns into the number of blocks. So what do we do to that figure number? So what do we do to a number 1 to turn it into a number 5? Well, one thing we could do is we could add 4, right? Now let's see if that works for the rest of the table here. Is 2 plus 4 equal to 6? Yes. And is 3 plus 7 equals to 7? Then yes. So this is what is happening here. This is actually, believe it or not, the hard part. Now we come up with a algebraic expression. So to get the number of blocks, so I'll just put number blocks just for short. What we do is we take our figure number, so I'm going to use n for number, and we add 4. Okay? So n plus 4, this is our expression. And when we look at the whole thing, we call that an equation. So if I asked you, for example, figure number 125. So if we were to extend this table all the way down to number 125, how many blocks would be in it? Now you could do it the long way by just extending this table and calculating every single figure number up to 125, or you could just apply our expression. So you could say the number of blocks is equal to 125 plus 4, and that is equal to 129. So figure number 125 would have 129 blocks. All right, well, let's try another example here. The numbers in column B and A are not related by addition. Let's try multiplication, because I could say, well, I can add 2 to make 3, but then that doesn't hold true for the other ones. So we have to figure out a rule that's going to apply to this entire table. So adding 2 doesn't work. What do I multiply by 1 to make 3? Well, I can multiply it by 3, right? Now, does that work here? Is 2 times 3 equal to 6? Yes. And is 3 times 3 equal to 9? Yes again. So that is our rule. We multiply by 3. And our expression would say A times 3 is equal to B. So if I take the number in column A, multiply it by 3, I get the number in column B. If we simply write it as it is, 5n, 5, 3, it looks like the number 53. So if we put brackets around it, then we know it's 5 times 3. Okay? So to avoid confusion, we put the brackets in place so that it's clear that it's 5 times 3, not just the number 53. Remember BEDMAS, we do multiplication before addition or subtraction. So all of these are multiplications, so we do those first, and then we do the addition or subtraction. Pause the video, come back when you're ready. So here we have 3 times 5 plus 4, so we have 15 plus 4, and that is equal to 19. Here we have 2 times 3 plus 7, so 2 times 3 is 6, plus 7, and that is equal to 13. Here we have 3 times 4 minus 5, so we have 12 minus 5, which is equal to 7. And 2 times 4 minus 7, 8 minus 7 is equal to 1. Using different variables in the same expression doesn't change the meaning of the expression. So that's basically telling us that it doesn't matter what the letter is that we use, it doesn't change the expression. So all 4 of these expressions mean the exact same thing. All right, that's it for our lesson. Go ahead and work on page 7 to 8 in your JUMP math book. Please ask your teacher if you have any questions. Sometimes algebra is a little bit hard for some people to get. With practice and with a positive attitude, you will all be able to get it. Good luck.